This is what electron transport chain looks like, similar to photosynthesis. That's also called electron transport chain because it's a step-by-step system, basically. NADH and FADH2 donate their electrons. They get oxidized, basically, donate their electrons to electron transport chain, where energy from these electrons is used to produce many ATP. So how's that happening? You had this NADH that carried electrons, turns into NAD plus once those electrons are donated. Those electrons, and this is the inner membrane, that's where the electron transport chain is happening, go from one molecule to the next. They're high in energy state. As they are moving through, they're pumping these hydrogen ions inside. Like I said last time, it's like filling a balloon with air. And if you poke a hole in that balloon, then the air wants to leave. The air wants to go out. So it's pumping the hydrogen ions inside. It's filling it up like a balloon. And when you look at the concentration of hydrogen ions, it's high here and low here. So they want to leave. And when they leave through ATP synthase. You have the same molecule here as when we went over photosynthesis. So they want to leave through ATP synthase. When that happens, it's going to take ADP and a phosphate and going to attach it, produce ATP. This is really, really awesome what happens here. And they don't still fully understand how this happens. How is it able to do that? So it's going to produce energy as that happens. And these electrons at the end are picked up by oxygen and they get reduced to water. So that's a byproduct. So that's why I said when you do cellular respiration in your body, water is produced. So there's some water that's produced. So I'm going to show you an animation and I'm going to let it run, kind of see, if it makes sense to you guys a little bit. So there's this animation. And these hydrogens, they can be called protons or hydrogen ions. So I'm going to let it run for a second and then I'll go over it. Okay, so I'm going to go over it now. So show you what's happening. So those NADHs, they're going to the electron transport chain. They're carrying the electrons. Those electrons start going through this electron transport chain or the molecules. When they do that, they're going to pump the hydrogens inside in the matrix. This is the matrix. And it's going to keep doing that. And that's going to create high concentration of hydrogen ions here compared to here. And these hydrogen ions want to leave. They leave through something called ATP synthase. This is ATP synthase. When they leave, that's going to produce energy. And that way that's going to happen, it's going to take ADP and it's going to attach phosphate to it and produce ATP. So these hydrogen ions, as they leave, they take ADP, put it with the phosphate and produce ATP. So that's what's happening here. That reminds me of water. Let me see. So that's basically the same concept. So here, so here in this photo, maybe you can see there's water that's backed up here. This is similar to these hydrogen ions. It's similar to these hydrogen ions that are backed up there. And then this water, if you poke a hole, let me see. I'm trying to look for animation or a photo, this cartoon drawing. So here, maybe. So the water, that's hydrogen ions, it's backed up there. So it's similar to these. And then if you poke a hole, in this case, we have ATP synthase. So this is ATP synthase. these hydrogen ions wanna leave. They try leaving, and there's this turbine there. So ATP synthesis has this engine, basically, that they're still trying to understand. And it's gonna spin the turbines, and it's gonna produce energy. And that's what's happening. Similar concept, that's what's happening here. When they leave, they take ADP and phosphate, put it together and produce ATP. And these are called protons or hydrogen ions. You can call them either or. As electrons travel through the transport chain, carrier molecules use the potential energy of electrons to transport hydrogen ions into intermembrane compartment. This is basically saying, so what I just went over, so these hydrogen ions, they're being pumped inside, they're high in concentration here, and they want to leave. So they're pumped inside in the intermembrane compartment, and the final electron acceptor is water. Hydrogens combine with oxygen to form water. And then the hydrogen that's inside, high in concentration, they want to leave from high concentration to low, and that makes a concentration gradient because high in concentration here, and it wants to leave, and it leaves through ATP synthase. That produces ATP. Total ATP that you get is 34 ATP. And again, that's coming from those NADHs. We put in 10 NADHs and then 2 FADH2 in this. Each NADH produces three ATP. So that's gonna give you 30. And then each FADH2 produces 2. And that's gonna give you 4. That gives you total 34. So I'll take questions if there are any questions on this so far. No question, then give me thumbs up so I can move on to the next slide. Yes, okay. This is the overview basically. So Krebs cycle, you get NADHs, FADHs, goes into the electron transport chain, and it's gonna break it down more. So each step is breakdown of food increases. So it's gonna break it down even more and get the energy out, ATP. And again, out of this, you got total 34. You got 2 here from Krebs cycle, and you had 2 from glycolysis, total of 38. So maybe memorize that number somewhere, write it down. Here it says 36. And the reason for that is because the NADHs from Krebs cycle needs to be carried to the electron transport chain. So total you had 38, but then 2 of them were used to carry these NADHs and FADHs to the electron transport chain. So glycolysis and Krebs cycle each produces 2 ATP. Electron transport chains produces 34. Transporting NADH to the mitochondria requires 2 ATP, making the total production of 36. I'm trying to remember, I think it's either here where it needs ATP to bring it to mitochondria from the cytoplasm, or here. But just know that 2 ATP is needed to transport those NADHs.